Today, we're going to talk about a design tool that's been hiding in plain sight for, about 3.8 billion years. It's this incredible idea of looking to the natural world, not just for resources, but for truly brilliant solutions to some of our toughest challenges. So, let's get into it. And to really get what this is all about, I've got a little puzzle for you. The three things you're about to see, they seem totally unrelated, but trust me, they share a secret that's completely changing how we invent our future. Okay, here it is. A bullet train, a prickly little burr that gets stuck on your socks after a hike, and a massive high-rise building. What in the world could they possibly have in common? Well, for starters, they all solve some pretty tricky human problems. You know, things like noise pollution, how to fasten things together, and how to stay cool without a giant energy bill. But that's only half the story. The real secret, the mind-blowing part, is where the solutions came from. They didn't come from some high-tech lab. They came from nature's R&D department, which has been beta testing ideas for nearly 4 billion years. And this is the whole idea behind biomimicry. So what is it officially? Biomimicry is the practice of consciously learning from and then mimicking nature's proven strategies to solve our own challenges. The real shift here is moving from thinking about what we can take from nature to what we can learn from it. It's a huge difference. And you know, even though the word biomimicry sounds super modern, this idea is actually ancient. It goes all the way back to umbrellas inspired by lily pads in ancient China, and of course, Leonardo da Vinci studying birds to design his flying machines. But more recently, the invention of Velcro and then Janine Benyus's groundbreaking book in 1997 really brought this idea into the modern playbook for innovation. Okay, so let's get into the really cool stuff. Let's look at some incredible modern examples where engineers who were stuck on a really tough problem found their breakthrough by, you guessed it, looking at an animal. This is a perfect example. So Japan's Shinkansen bullet train was so fast that when it exited a tunnel, it created this massive sonic boom from all the compressed air. It was a huge problem. Then an engineer who happened to be a bird watcher had an idea. He looked at the kingfisher, a bird that can dive from the air into water, two totally different mediums with almost zero splash. Why? Its beak is shaped to part the medium smoothly, preventing a big pressure wave. So they redesigned the train's nose to mimic the beak, and boom, no more sonic boom. And get this, as a bonus, the train became 10% faster and used 15% less energy. How cool is that? And of course, we have to talk about the classic example, right? Velcro. Back in 1941, a Swiss engineer named George de Mestral came back from a hike and was super annoyed by all the little burrs stuck to his dog's fur. But instead of just throwing them away, he got curious. He put one under a microscope, and what he saw was genius. A brilliant system of tiny flexible hooks latching onto loops of fur. And just like that, the idea for Velcro, the hook and loop fastener, was born, a direct copy of nature's simple, elegant design. Now this is where things get really futuristic. To make solar power way more efficient, researchers are now looking at the black butterfly. Its wings aren't just black because of pigment. They have these incredibly complex, jagged structures at a nanoscale that are brilliant at trapping sunlight from almost any angle, preventing it from reflecting away. By copying that structure, we can design solar panels that are way better at soaking up the sun all day long. Okay, so we've talked about copying shapes, but what if we could copy processes? Like really complex biological stuff, like the incredible ability to self-heal. I mean, just imagine a phone screen that could actually fix its own scratches. So how in the world does this even work? Well, one of the cleverest methods is called microencapsulation. Just think about it like this. A material is filled with millions of microscopic bubbles, and inside each bubble is a liquid healing agent. When a crack forms, it's like a tiny earthquake. It breaks open the bubbles. That liquid flows out, fills the crack, and then hits a catalyst that's also mixed into the material. The two react, and the liquid hardens, sealing the damage shut. It's almost exactly how our own blood clots to form a scab and heal a cut. And the possibilities for this stuff, they are absolutely huge. I mean, we are talking about concrete bridges that can heal their own cracks, airplane wings that repair tiny fractures while they're in the middle of a flight, and yep, smartphone screens that can literally mend their own scratches. It's a total game changer, a step toward making things that are actually built to last. So you can see all of this, it's more than just a bunch of clever engineering hacks, right? Biomimicry is pointing to something much deeper. It represents a really fundamental shift in our relationship with the natural world, from seeing ourselves as its conquerors to seeing ourselves as its students. You know, for centuries, we've pretty much viewed nature as an object, something to either exploit for its resources or something to put a fence around and protect. Biomimicry invites us to make a shift, to start seeing nature as a source of amazing ideas, a mentor, and a model for how to build a world that actually lasts. Janine Benyus, the biologist who really brought this idea to the forefront, she summed it up perfectly. She said we should see nature as a model, giving us blueprints that we know already work. We should see it as a measure, giving us an ecological standard to judge our own inventions against. And finally, we should see it as our mentor, teaching us a way of living on this planet that's sustainable. But hold on. Before we get too carried away, there's a really important catch here. It's not as simple as just blindly copying everything we see out in the wild. We have to be really smart about which lessons we choose to learn. And this brings us to this big philosophical idea, the naturalistic fallacy. It's this flawed assumption that just because something is natural, it must automatically be good or moral. But think about it. Nature is also full of predators, parasites, and brutal competition. Those are things we definitely don't want to copy into our own societies. So this leaves us with a really critical question, a question for any designer or innovator out there. A spider's venom, for example, is a marvel of biochemical engineering, right? But does that mean we should copy it to make a weapon? Of course not. This is where our own human ethics have to come in. We're not just looking for solutions that are effective, we're looking for ones that line up with the kind of sustainable, cooperative world we actually want to build. All right, so after all that, where are we headed? What does a future really guided by this kind of thinking actually look like? Well, it's a future where we start tackling our biggest, scariest problems, from climate change to resource scarcity, by first asking a simple question. How has nature already figured this out? We stop trying to reinvent the wheel from scratch and instead go consult this vast, brilliant library of solutions that's all around us. Just think about that number again. 3.8 billion years. That is the sheer scale of research and development that has gone into every single living strategy on this planet. It's the longest running, most successful beta testing program in the history of the universe. And it's ours to learn from. And that really leaves us with this one final kind of mind-bending thought. Biomimicry totally reframes what it means to be an inventor. It suggests that maybe our next great breakthroughs won't come from inventing something brand new, but from finally truly understanding something incredibly old that's been hiding in plain sight all along.